Hello students, welcome to LJ Institute of Engineering and Technology. Here myself Mr. Jaiswal Kishan from Civil Engineering Department, and we are learning all about earthquake engineering. Let's start our today's session. Now in today's session we will be starting with the examples related to the portal method. So I hope you remember these steps which we have carried out during previous session. So with the help of these steps only we will be following the example. Let's have a look. Analyze the building frame shown in figure by portal method and draw shear force, bending moment and axial force diagram. So this figure will be given in the question itself. Now focus that these are the point or say junction A, B, C, D, E, F, G, H, I, J, K, L, N, O, P, Q. These are the various junction points, and the bay width is of 4 meter of each one, and height is of also 4 meter for each one. Now the horizontal forces are given, so which is 24 kilonewton over here and 18 kilonewton at the top. Now this is the given figure. Now let's start our example. So our first step is using column shear. So in the previous slide you have seen that first step is column shear Q, and at the end it is only Q, and at the intermediate it is 2Q. So for this one we will be considering Q value, and for this and this we will be considering 2Q. This is a step. So we will be starting from top to bottom. So story number 3. So this is my story number 3 for this particular floor, and this is my story number 2, and this is my story number 1. This has been assumed. Now story 3, there is an 18 kilonewton of horizontal force which is acting. So for this column it will be Q3. For this column and this column it will be 2Q3, and this one is for Q3. Q is shear force, shear at the ends, and 3 is particularly story number. So it is equal to 18. So this is an 18 kilonewton load. So 6Q3, 2 plus 2 plus this 2 equals to 6Q3 equals to 18, and Q3 value is coming out to be 18 by 6 is 3 kilonewton. So shear force at each column end is 3 kilonewton and 6 kilonewton at intermediate column. So this particular column will be having 3 kilonewton of load, and for intermediate, which is a 2Q, so it will be a 6 kilonewton. Now we are coming out to be at a story number 2. So over here same formula, but Q2 plus 2Q2 plus 2Q2 plus Q2. Now the forces will be accumulated. So this is my 18 kilonewton plus 424 kilonewton. So it will be 42 kilonewton. So 6Q2 equals to 42. So Q2 equals to 7. So over here and over here the forces will be 7, and at the intermediate it will be 14. Similarly at the last same formula, but the forces will be accumulated. 18 plus 24 plus 24 is coming out to be 66, and Q1 equals to 11. So at each end it will be 11, but at the intermediate level it is at 22. So look, like this I have shown the forces. So as in the steps as well, it has been mentioned, or say in the theory portion it has been mentioned that it will be equally and opposite direction. The forces will be placed at equal and opposite direction at the column. So these are my shears which is equally and opposite. So look, you can see the values we have found out we will be placing over here. So this is my first step. Now next step is, with the help of column shear we will be finding out column moments. So this is my step number 2, column moment. Now here I have assumed anti-clockwise as a positive and clockwise moment as a negative. Now look, for each column we will be finding out the moment. So look, here I have considered this column as an Ni. So over here, if I am standing over here, the moment will be Mni. If I will be standing over here, the moment will be Min. Look, Mni equals to Min. Why they are equal? Because the forces are equal in this particular column also and this particular column also. So Mni equals to Min equals to Mql equals to Mlq. So this all 4 junction points, the moments will be equal, which is nothing but 3 multiplied by half of the distance, h by 2. So h is my 4 meter, divided by 2 is nothing but 2. So 3 is the force multiplied by 2. So 3 2s are 6 kN into meter. Now I am coming to the sign. Now look, if I stand over here, then this 3 kN is making a clockwise kind of movement. So I said that I am assuming clockwise as negative, so that's why negative. If I am standing over here, then this 3 kN load is making a moment of clockwise, which is again negative as well. So this is my 4 moments which I have found out for this and this column. Now for MOJ equals to MJO plus equals to MPK equals to MKB. So these 4 moments will be similar. The forces are similar. So 6 into 2 is nothing but 12. Similarly for story 2, if I am standing over here, 7 multiplied by 2 14. So first one is 14. 14 multiplied by 2 is 28. So second is 28. So we have found out till here. Now at the last 11 multiplied by 2 and here 22 multiplied by 2. So we have found out the column moment. It's quite simple steps. Just need to keep in mind the direction as well as the sign which we have assumed. Now with the help of this column moment, we will be finding out beam moment. So look, I have made a figure for column moment. So look, as it is clockwise, so all the direction has been clockwise. So it will be at both the end. Here it is also 6 kN and here it is also 6 kN into meter. I have just shown the single diagram. So this I have made for the reference to use in the next steps, which is step number 3, which is my beam moment. So now beam moment will be finding out by considering each joint one by one. So consider each joint as a free body diagram and apply summation of moment equals to 0. Here also anti-clockwise is positive and clockwise as negative. Assume unknown moment as positive, that is an anti-clockwise. So these are the 3 points. Like as first of all, we will be considering free body diagram of each of the joints, and then the moment which we have assumed in the column part will be similar. Just assume over here the moment which we need to be find out need to be considered as anti-clockwise or say positive. So let's start one by one. So now we'll be again starting from the top story and all the top junction points. So let's start with the point N. So I have looked out this point N and its adjoining members are N to O and N to I. So right now we are finding out the moments for the beam portion. So we will be taking one by one. So this is my point in which this 6, which we have already found out in previous step, step number 2, which is a clockwise moment, and as in the step it has been mentioned that assume this as an anti-clockwise as a positive direction. So let's see how to solve. Now summation of m equals to 0 at this point. So mni, which is over here, plus mno equals to 0. This has been assumed. Now this look, it is in clockwise, so it will be -6 plus mno equals to 0. So mno is coming out to be 6 kN into meter. So it is just a simple step. Look, summation of moment equals to 0 and both the moment has been summed up, and then find out the value of the unknown. Look, this I have placed off this moment as it is we have assumed in a clockwise direction, and it is coming out to be plus only, so it is an anti-clockwise. Now we will be taking out the junction O. So adjoining members are O to N, O to P and O to J. Now look, at this junction we will be taking summation of moment equals to 0. So MOP plus MON plus MOJ equals to 0. Now look, this column moment which we have already found out, this beam moment which we have found out in just recently. So with the help of these two values we can find out the third one. So this is an clockwise, so it will be minus. This is an anti-clockwise, so it will be plus. So MOP plus 6 minus 12 equals to 0. It is MOP equals to 6 kN into meter. So I have placed again as it is. Now the next step is this. We'll be using this junction point, P point. So this is my two beams. So this moment we have recently found out, and this which we have earlier found out, and MPQ will be found out. So MPQ plus MPO plus MPK equals to 0. So MPQ will be coming out to be 6 kN/meter. Similarly, one by one we will be finding out the moments. So look one more time. So this is my I junction. Adjoining members are I2J, I2N and I2E. So for the column moments we have already found out this is MOT. Just this has been need to be found out MIJ. So MIJ is coming out to be 20. How? This 6 plus 14 is nothing but 20. So MIJ equals to 20. Similarly, the J junction point where 4 members are meeting. This is my column moment which we have already found out in the step number 2. This moment we have recently found out. So by summation of it, we will find out this MJK moment. Similarly, MKL, then MEF, MFG and MGH. So this we can find out with the help. Now the next step is step number 4 for beam shear. So what we do? First of all, we took column shear. With the help of column shear, we have found out column moment. With the help of column moment, we have found out beam moment. And now with the help of beam moment, we will be finding out beam shear. So similarly, the moment divided by distance by 2. So M and O divided by 2, here it is 6 by 2 equals to 3. Similarly, over the story number 3, all the values are similar, so 3. Here 20 by 2 equals to 10. Here 36 by 2, it is coming out to be 18. So these are my various shear force for particular beam member. So like this I have drawn. So as it is mentioned that it will be equivalent in opposite direction. So here it is upward, here it is downward, upward, downward, upward and downward. Similarly, we can place. So we have completed the 4 steps, moments and shears for beams and column as well. Now we will be shifting towards the axial forces. So column axial force. Consider each joint as a free body diagram and summation of V equals to 0. Similarly, in the step number 3, what we did, the same kind of thing we need to do in the upcoming steps. So look, this is my N to I point, N to O point. So I have taken out. Now this was the shear for column and this was the shear for beam. Now here summation of V equals to 0. So while discussing the steps, I have said that the beam shear will be considered in this point, but this will be considered in the beam axial force. Now here we are considering summation of V equals to 0. So this is my vertical force, this is my horizontal force. So this will and this will not need to come directly, this will be coming. Now what we need to be assumed. So here I have assumed upward as a positive and downward as a negative. So the force is coming in upward direction. So for this particular member Ni, I have assumed as SNI name, and for it the opposite to it I have assumed as it is going upwards, I have assumed as a downward. So summation of V equals to 0. 3 minus SNI equals to 0. So 3 it is going upward direction, so positive, minus SNI which is going in downward direction. S is an axial force for particular column and I member equals to 0. So SNI is coming out to be 3 kN in a tension zone. Now how it is tension? Look, if I am standing on this point, that SNI is going away. So if something is going away, it is pulling it. So it is in a tension zone. Next is this O junction. So members are N2O, O2P and O2J. Now this one is downward, this one is upward. So while standing on over here, the SOJ will be having equal and opposite this forces. So ultimately for this particular member, the force will be 0. So for SOJ will be 0. Similarly for P also, as this is going downward and this is going upward, the summation of V will be equal to 0. So for PK member, it is also 0. Now for QL, as this is going downward, so I assume this one as an upward. So SQL minus 3 equals to 0, so SQL equals to 3. Now it is going towards the joint Q, so it is in compression. Similarly, for rest of the portion we can find out. Look, now this how we can find for I joint. There is a member for N to I to E, and I to J is a beam. Now look, this we have found out in previous slide. So we have found out, look, over here it was coming downward. So equal and opposite need to be placed. So I have placed at both the point. Now this force will be over here, which will be helpful for solving the summation of B equals to 0. Now calculating this force is over here. Summation of B equals to 0. This one is upward. So positive 3 plus positive 10 minus I have assumed as SIE equals to 0. So SIE will be equals to 13 in a tension as it is pulling. Similarly, here the forces was 0. So here it will be 0. So up and down will be coming out to be 0. Similarly for K as well. And for over here, this one is coming out to be downward. This is also coming out to be downward. So this is value is 3. Here it is 10. So it is coming out to be 13. I have assumed SLH as an upward. So these are the forces. Similarly, whatever the forces, place equal and opposite and find out the rest of the value. So I have found out for each of the joints. So now after calculating column axial forces, now we will be finding out beam axial forces, just similar to the previous step, but right now over here we will be considering summation of H equals to 0, in which column shear will be considered. Look, let me show you one. Now this is my N I portion, my N I and to O member. Now this will also come because as it is an horizontal load. So summation of H equals to 0. Here right side I have assumed positive and left side I assume negative. So this is left, this is right. So plus 18 minus 3 and this I have assumed in the left side direction. So SNO equals to 0. So SNO equals to 15, which is in compression as it is going towards the joint. So why I have assumed this SNO is towards the joint or towards left direction? Because you can see both the forces, this one is highest one, so it is going in the right side direction. So I have assumed this one as a left side direction. This you have to be keep in mind by solving the example. In which direction need to be assumed. Now, as this was coming out to be 15, equal and opposite need to be placed. So now at O junction, this 15 is coming over here. This is N6 and SOP I have assumed on the left side direction because the major one is this 15. So summation of H equals to 0. 15 minus 6 minus SOP equals to 0. So SOP equals to 9. Similarly for P joint, P to O, P to Q and P to K, we can find out SPQ. Similarly SIJ, which is over here, then SJK, then SKL, then SEF, SFG and FGH we can find out. So after finding out all the axial forces in the beam as well, so we have completed all the forces like a shear force in beam and column, bending moment or say moment in the beam and column, and lastly axial force in beam and column as well. So last we need to draw the diagram. So look, it is quite simple. You have to draw the bare frame, which is like this, and you have to show the values. So look, this is my column value, so which I have shown in the blue color. So this 3, this is 6 and 3. Similarly 7, 14, 14 and 7, 11, 22, 22 and 11. Whatever the direction you assume for the one, you have to follow for the both. Now next is for beam. So 3, 3 and 3 it is common, 10 is common and 18 is common. After shear force, the bending moment. So look, this is my column moment. So here it will be passed from the point of contact tension at the mid height, which we have assumed. So here it is a 6 and then it will go towards the 6 as well. So 6, 12. Over here, this one is blue one is for column 1 and this all is 6 value for beam. Similarly, for all, we can find out. You can assume this as an outside and this as an inside. So whatever the you will assume to just follow uniform for the all. Right now here we are not keeping any positive side or negative side. Lastly, axial force. These are my column axial force. So which is shown in this blue color, this 3, 13 and 31. And we have got the intermediate column having axial force as 0, so there will be no figure for it. And at last, this one 3, 13 and 31. Now these are my beam axial. So 15 for first, then 9, then 3, 15, 9 and 3, 20, 12 and 4, and similarly 20, 12 and 4 as well. So likewise this, we can draw all the diagram. So that was all for the example. I know this is a quite lengthy example, but the process is very much easy. So you have to perform various steps for example.